Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is integration. What you are going to learn today is how to find the integral of an exponential function. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the integral of an exponential function as one of the types of basic functions also. So this is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in your favorite segment of each lesson today, I'll give you another interesting number. And this number is 17. 17 is so special, so unique, so amazing. I will explain what is special about this very number after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us learn the rules. It is this rule that tells us what to do in attempt to find the integral of an exponential function. So let's take a general case of exponential function y equals to e raised to the power of ax. If this is a general exponential function and you wanted to find the integral of this very function. So the integral of e raised to ax with respect to x. So the rule tells us that this integral will now be nothing but 1 over a multiplied by e raised to the power of ax plus c. This is the guidelines. This is the rule. If you are to find the integral of, for example, e raised to the power of 2x, then that integral will now be 1 over 2 e raised to the power of 2x. That exponential function, you now just copied it. That is the term with the exponential function, you copied it. But the coefficient of x is what you are going to use here as your denominator of this very fraction, 1 over e. We are going to take examples how we can make use of this rule and find the integral of some exponential functions. So let's just move and take examples. Example number 1, the question asked here is to find y if you have y prime to be equals to 2 e raised to the power of 2x minus e raised to the power of minus 3x. Solution to this very problem. So what you do, remember, if you have the y prime simply refers to derivative of the function y. This question says find y, which means, remember our first lesson in this integration, where we learned the relationship between derivative and integral. If you have a derivative and you find it is integral, what you now have as the integral is the original function back. So this case, you asked to find y. Y is the original function, but we have the derivative of y. So which means this derivative, what we need to do is to find the integral of this derivative. So finding y is just nothing but finding the integral of this y prime with respect to x. So let us move. So now find the derivative of this function y prime, which is now 2 e raised to the power of 2x minus e raised to the power of minus 3x. So I continue. So I will now replace my y prime by this. So I'm going to have integral, open bracket, inside the bracket is 2 e raised to 2x minus e raised to the power of minus 3x, then dx. We continue. So now apply my property of integration. I have 2 terms here inside this bracket. So I can now say the integral of the very first term minus the integral of the second term. Let me just move ahead and do that. So this is now equals to integral of 2 e raised to the power of 2x dx minus the integral of the next term, which is integral of e raised to the power of minus 3x dx. So now find the integral of each of this. Remember the rule. If you have e raised to the power of 2x, for example, in this case, the integral is says 1 over this very 2, then times the exponential function, then plus the constant. Let me just do that. So integral of this very first term is now going to be this 2, which I just copied, times 1 over 2 e raised to 2x. Look at it, 1 over 2. Why this 1 over 2? Because here the coefficient of x in the exponential term, the coefficient of x here is 2. The rule, remember, it says if you have e raised to ax, integral of that e raised to ax will now be 1 over a. 1 over a. So in this case, your a is 2. So you have 1 over 2. Then times that exponential term, which is e raised to 2x. Then minus this minus, I just copied it. I will not write plus c because I have another integration to do again. Then after I did that one, I can now plus the constant number c. So the integral of this is what I'm going to do next. This your a in this case. If we compare this with e raised to ax, so your a is now minus 3. And remember the integral, it says 1 over a. So you are going to have minus 1 over 3 e raised to minus 3x, then plus the constant of the integration. So I'm now do this multiplication. 2 times 1 over 2. The 2 cancel this 2. So I have e raised to 2x left. And this minus will now change it to plus. So I'm going to have e raised to 2x plus 1 over 3. E raised to minus 3x plus c. This will now be the y function. That is the y function that we asked to do. That is we asked to find. That is the result of finding the integral of the y prime. Let's just take one more example. Example number 2, we asked to find the integral of e raised to x plus 1. This 2 inside bracket and the bracket raised to the power of 2 dx. Solution to this very problem. Copying down the given text, that is integral of open bracket e raised to x plus 1, then the bracket raised to the power of 2 dx. So what I will do in this case, this bracket raised to the power of 2 means the bracket times itself. So let me do that. So I'm going to have integral of open bracket. Inside that bracket, you have 2 other brackets, and the 2 other bracket is just each one contain e raised to x plus 1 times e raised to x plus 1. So if I expanded this to inner brackets, if you do it correctly, that is e raised to x times e raised to x, it gives you e raised to 2x. E raised to x times 1, it will be e raised to x. 1 times e raised to x. If you do that correctly, the expansion of the 2 brackets, innermost ones, you're going to have e raised to 2x plus 2 e raised to x, then plus 1. So it is this now that I'll find the integral. I have 3 terms here. So properties of integration says you can now find integral term by term. So there you now have integral of e raised to 2x dx. That is the very first term. Plus the integral of the next term, which is integral of 2 e raised to x dx. Plus the integral of the next term, which is this constant number 1. You will now have integral of 1 dx. So I continue. So I will now find the integral of each of these terms there. Integral of e raised to 2x, based on the rule, it says 1 over 2, then times e raised to 2x. So I'm going to have 1 over 2 times e raised to 2x. Similarly, integral of this e raised to x, the coefficient of x here is 1. So you have 1 over 1, which is 1, then times this to 2. So you are just going to have 2 e raised to x, then plus the integral of constant number 1. Remember, integral of constant, it says that constant times x. So that gives you just x, then plus the constant of the integration. So this would now be the integral of this very function. This is why I've come to the end of this very lesson, my dear student. I hope with the few examples given, you'll be able to find the integral of an exponential function. And let me just move to the last segment, Marcy's fun, and explain what is interested about that number 17. So what is interested about this number 17? It says 17 is the only among the just very few prime numbers that can be written in this form. That is x raised to y plus y raised to x. What we notice in this expression, it is a sum of 2 index numbers, and those 2 index numbers, the base of the very first index is the center as the power of the second, while the base of the second index is the power of the first. This is what we noticed in this very expression. So 17 is just one out of very few prime numbers that can be written in this format. Let's just see how we can express this 17 in this format. So 17 is nothing but 2 raised to 3 added to 3 raised to 2. So you can see that's the 2, the base of the very first index is the power of the second, while the base of the second is the power of the first. Let me just evaluate what is 2 raised to 3 and what is 3 raised to 2. 2 raised to 3 gives you 8, and 3 raised to 2 gives you 9. And if you add 8 and 9, I tell you, you get 17 back. So 17 is a very interesting number. Thank you for your attention. We'll see more of this in our subsequent lesson.